Okay, so after today, we're going to be half done the unit. The note's pretty short, and you'll have lots of time to get your work done in class. Please be very respectful that when you get done your homework, you sit down and just keep to yourself. The good thing about keeping the work light is that everybody gets done. The bad thing is that some people start talking and then other people don't get done. So if you are totally done, you have your study sheet done, then you know what? Do something that doesn't talk to somebody else, doesn't bug somebody else, doesn't make any noise. Okay? So I'm sure you can think of something. Now, today, we're just going to do 2 examples. It's one of those ones where, okay, here's the steps, and I can just execute those. Okay? So you guys need to move your roll up here too, right? So there's no empty desk in front of you. Now, let's go right to page 459. We're just going to do example 2, example 3. Now, the part that we kind of skipped over is how to solve these graphically. Now, there's always 2 ways to do it. You can make it equal 0 and then find the zeros, or you could make it equals 0 still and find y1, y2, or leave it the way it is and do y1, y2. Now, I know this sounds almost counterintuitive, but I'd like to know the answer before I do the question. And you know what? That used to be the diploma when it had written response on it. Sometimes they gave you the answer and said, show all the work. Okay? Because the work's the important stuff. Like when I am marking a written response, I'm obviously looking for the work. Now, let's do this question on the calculator. Okay? So how do we do that? Well, it's a y1, y2 thing, right? So on the left side, we have absolute value. How do we get there? Math, right to number, and then there it is. Absolute 2x plus 3. And then y equals 8. Okay? And hit graph. Now, does everybody know what the answer, how you find the answer to this question? Okay, but what are the answers? Explain it to me on this graph. I don't need to know the numbers, but what am I looking for? I'm looking for this at the places they intersect, right? Those are the answers. Can you find them for me? And I'm just going to take a screenshot here and have it nice and available. So when I'm doing the question, I'm getting the right answer. Okay, what are the 2 answers? Negative.
Zach came up. Please come to the office. Zach came up.
Zach's already at the office. So say them again. I don't want them in decimal either. I want fractions. Okay, 5 over 2 is this one. And negative 11 over 2 is this one. Now the next thing that I need to know is what is this point right here? Can you tell me what this is right here? Yes. Good. What is the vertex? What is this is where it goes through the x-axis. What's that point? Anyone know? No. Come on. Second trace 0. Get to the left side of it, equals. Right side of it, equals. And then equals again. What are we getting? The silence is deafening. Negative 3 over 2. Now, if you know what to look for, this is how I would do a multiple choice question. If it asked me what are the answers, I would say negative 11 over 2 and 5 over 2. On to the next one. I find it almost weird when I'm walking around and people are doing something they can put into their graphing calculator in 1 minute. They're doing the long way for 5 minutes. Remember, it's multiple choice. And remember, that test is a game, right? There are tricks to every game you'll ever play. There are shortcuts. Okay? There are more efficient rules. And if it's multiple choice, I would graph it. Because I don't get any credit for doing it the long way. Now, maybe if it was... if it was my second time through the test and I'm checking it over, I might do it the long way because maybe I have to do it the long way for the written response. I want to see if I'm doing it right, getting the right answer. Oh yeah, okay. And you know how we always fear, oh don't show the graphing answer because he's going to think that's how I got it. Okay, I won't even erase that. No, put that up there. Okay, I'll take that opportunity anytime. Okay, so I know the answer before I start the question. Cool. Okay, now I'm going to go do it. Now, the way we do these is we will find the 0 when it's greater than 0 and when it's less than 0. Okay? Now, what I'm talking about is the absolute value. Now, absolute values algebraically are a little bit more complicated than if you do it in the calculator because we need to be able to find when this equals 0, when this is greater or equal to 0, and when it is less than 0. So first of all, let's find out when 2x plus 3 equals 0. Now, minus 3, 2x equals negative 3. Then divide by 2, x equals negative 3 over 2. Then I'm going to put this in the very middle. Okay, that's when my absolute value equals 0. Now, then I'm always going to do when x is greater or equal to negative 3 over 2 and when x is less than. Do you see how I've set it up? And I want you to look at the graph. Do you see where this equals 0? And when x is greater than this number, greater than equal to, and then less than. See, this side gets greater or equal to, this side gets less than. Now, when x is greater than negative 3 over 2, is this positive or negative? Positive. So if it's positive, I'm just going to drop the absolute value when 2x plus 3 equals 8. Because anytime, now I can solve for x when the absolute value is positive. So when the absolute value is positive, next thing I will subtract 3. 2x equals 5. Then I will divide by 2. X equals 5 over 2. Okay? Now, is 5 over 2 in the subdomain? That means, is it greater than negative 3 over 2? So the answer is yes. Therefore, it is one of the solutions, 5 over 2. Now, I got to get the other one. And I've already ruined this surprise because I know what that other one is. But how can I show that algebraically? Well, if you ever put anything into this equation less than negative 3 over 2, the thing inside the absolute value is negative. But I need to make it positive. So then I'm going to multiply it by negative 2x plus 3. See the negative? It's very similar to yesterday, but we're just dealing with the... Now, are we including the 8 at this point when we do that negative? No. We're just messing with the absolute value. So this is negative 2x minus 3 equals 8. We'll add 3 to both sides. Negative 2x equals 11. Then divide by negative 2. X equals negative 11 over 2. Is that in the subdomain? That's negative 5.5. Is negative 5.5 less than negative 1.5? Yes. So this is also a solution. Now look on your graph. Or look on the graph. See where negative 3 over 2 was? See where negative 3 over 2 is in our chart. See where 5 over 2 is? See where 5 over 2 is on our chart. Now, do you see how you would not come up with negative 11 over 2 without doing both cases? You have to be able to algebraically show how to find both. Okay? Now let's do another one. We're going to do the same routine. Okay? Now, what should I do first? Graph it, yes. What am I graphing? Left side, which is, well, turn on, y equals absolute value 3 plus x. And this is 2x plus 1. And hit graph. Okay, just draw it quickly. Okay. What is the solution to this? Let's find the answer before we even do the question. Yell it out as soon as you get it. 2. Anything else significant on this before we go solving the question? Negative 3. No, it's just not just the vertex. It's the vertex touching the x-axis. Okay? Now, so that's not asked anywhere. Read it. It does not say graph this and then. Okay? Now remember, you're not robots. You can actually do some thinking. And this isn't cheating. That little black box with all the buttons on it, you're bringing that into your diploma. So if it can do it, get it to do it. On your diploma, if you know an easy way to do it in your graphing calculator, you'd be nuts not to do it, I think. So, I got the answers. Now I'm just going to go and do this. So even if we pretended we didn't know the answers, how would I start this? Who remembers? Yeah, I got to do that one in the middle. How do I find that one in the middle? When does 3 plus x equal 0, right? So we go, when does 3 plus x equal 0? You just mess with the stuff inside. when x equals negative 3? What do we put on the right? X is greater or equal to negative 3. And on the other side, when x is less than 3. Now I want you to test this out. When x is greater to negative 3, what would it do? Yeah, I forgot my negative. What would it do to this? Would it make this positive or negative? When x is greater than negative 3, you would make it positive. So do we have to do anything to it? No. So then that just becomes 3 plus x equals 2x plus 1. Now, do some quick algebra. I'm going to minus 2x here. It gives me negative 1x. I'm going to minus 3. That is negative 2. I'm going to divide by negative 1. X equals 2. Is this in the subdomain? Is x greater or equal to negative 3? Is 2 greater or equal to negative 3? Yes, no, maybe, sometimes, what? Okay, yes. So we know 2 is one of the answers. Now, if you put in anything less than negative 3, like negative 4, what's 3 plus negative 4? Negative 1. That's not absolute. So when x is less than negative 3, we're going to have to put a negative in front to make everything positive. Notice I'm not touching the 2x plus 1. I am just doing the absolute value. So this is negative 3 plus x equals 2x plus 1. Oops. Okay, so it was supposed to be 3 plus x. So it's negative 3 minus x equals 2x plus 1. Now I'm going to minus 2x. That gives me negative 3x. I'm going to add 3. That equals 4. Divide by negative 3. X equals negative 4/3. Now negative 4/3 is negative 1.3333. I'm only doing that because some people aren't good at. Now, is that less than negative 3? No. So is this in the subdomain? No. Therefore, it is not a solution. So the final solution is 2. Okay. Let's go do what are your homework? Number 4F. 4F is tricky. Okay, it's always good to be the second class because we did this in the first class, but after. So let's look at this one. Now, can we do the graph quick, please? And see what it looks like. Know the answer before you start. Okay. Do you think these two will ever cross? I think so. They're not parallel, are they? So it's going to happen more up here somewhere, right? How do we find that spot? What do we do? Change the window. And what would I change? X? I think I need to see higher, right? So let's do y max as like 20. Okay, so I am still not seeing, I think I'm high enough. Now what should I mess with? Y x 10, right? Make that negative 20. Okay, so that's the first thing that we need to be learning here. So just draw that graph quick. Again, it doesn't have to be huge, it doesn't have to be perfect. But just to have it there. And what's the answer? Negative 14. So this is negative 14. What's another valuable thing that I should know? This point right here. The bottom of the V, what is that? Yeah, what's the number? That's 4. Okay, now let's just talk about this. When is 4 minus x equal to 0? Negative x equals negative 4 when x equals 4. Okay, so we do our chart. This is when x equals 4. This is when x is greater or equal to 4. And this is when x is less than 4. Now, if we have 4 minus x equals negative 2x minus 10, what happens if I put in anything greater than 4? What happens? What's 4 minus 5? Negative 1. What's happening different in this one? We have to plug the negative to this side to make sure everything's positive. Okay? So we're still going to set up the chart the same, but it actually sometimes affects the question differently. And when x is less than 4, say 3, 4 minus 3 is 1. See, when it's less than 4, we can just leave it as 4 minus x equals negative 2x minus 10. Does everybody understand why this one's different? No? We'll test it. What is a number greater than 4? 5. So if you put it in here, 4 minus 5 is negative 1. I must multiply it by a negative to make sure it's positive. So you always want to test this in here to decide, am I going to put it in brackets with a negative, or am I going to leave it alone? Okay? So that's why this one, make sure you are, so you're doing, I'm not going to finish it, you have to finish it. Doing 1 to 4 all.